Hi everybody, and welcome back to our expertise Juniper sessions. Some of you might have been here this morning. My name is Yasmin Lara. I'm a Juniper instructor with Untitled Learning Institute. I'm a JNCIE. And my email address, in case you guys have any questions, it's ylara@untiltledlearning.com. And today I will be talking about security zones and functional zones, SRX zones in general, which is one of the main components, the primary components of security policies, and the way that the SRX firewalls in Juniper implement all the stateful firewall functions to filter traffic and implement security basically. So here's our agenda. I would like to talk about what a zone is. There's different types of zones that we're going to discuss: the null zone, functional zone, Junos-Host zone, the security zones. We're also going to talk about how routing instances and security zones interrelate. There's some rules on how to configure routing instances and security zones on an SRX box. We'll also talk about zones within the packet flow process. In fact, we're going to review how packet flow processing happens on an SRX with all the different components. And we'll talk a little bit about security policies, trying to understand how security policies interact with zones. And we're also going to talk about the host inbound traffic command, which allows, as the name tells you, inbound traffic into a security zone. Traffic terminating into your SRX box. So a zone is a collection of one or more network segments which are going to have identical security requirements. So what you're doing is grouping together interfaces that will be treated the same way in terms of security. Maybe interfaces connected to a group of users who are going to have access policies that are the same. They will be accessing the same resources in the network, for example. These are interfaces that will have the same policies in terms of how to access the SRX itself, and so on. A security zone, or a zone in general, is a building block for security policies. We'll see in a little bit that security policies reference zones to control transit traffic. In other words, when you configure a security policy, you define traffic from zone X going to zone Y is going to have these policies applied. So you defined the direction of the traffic that's going to be inspected and checked against that security policy in terms of the inbound zone and the outbound zone for that traffic. There's again different types. I said here 3 types, so in fact 4 different types. There's a null zone or default zone which doesn't pass any traffic at all, and all interfaces by default are part of this null zone. What that translates into is your interfaces will not be able to accept any traffic, to pass any traffic, until we move that interface from the null zone to usually a security zone, in some cases a functional zone. So interfaces will not allow any traffic at all until you have created a security zone or a functional zone and you have attached that interface to the security zone or functional zone. The only exception to that rule is the SXP0 interface, which, as you probably know, is the out-of-band management interface on your box. So that interface doesn't require any security policy, any security zone. In fact, you cannot configure that interface inside any security zone. If you try to do that, you're going to get an error message when you try to commit your configuration. So here's an example where you have a typical network topology where there is a central site, and then you have some branch offices or home offices. And what we're doing here is setting up some IPsec connectivity across the internet to set up these remote access or access between the central site and the branch offices and so on. And notice that all the networks are configured within a specific security zone. Again, the interfaces won't be able to allow any traffic whatsoever until you have placed those interfaces inside some kind of zone, security zone or functional zone. So in this example, you see that all the interfaces in the central side are either part of the marketing zone, the administrative zone, or the engineering zone, while the private zone, the branch office has a private zone, and same thing in the home office. Now, the connection to the internet is going to be part of either a public zone or a VPN zone where I have my IPsec tunnels. And by the way, all these zones are custom-based. I mean, I decide how I want to call them, I decide how many I want, I decide which interfaces are going to be part of which zone, and so on. If I don't want to have these two zones facing the internet, but have my IPsec tunnels and my internet traffic terminate on the same security zone, I can do that. It's all up to you. Now, once I have my zones implemented, I need to configure security policies that will allow traffic to flow from one zone to another zone. So zones and policies go hand in hand to implement connectivity and security across an SRX box. Notice that also in this administrative zone, or actually the marketing zone, I have two interfaces part of that same zone. So even for traffic between these two interfaces, again, part of the same zone, I would need to write a security policy to make that traffic work. So we'll talk about, or we'll not get into the details in these in this presentation, but we'll mention that security policies are either inter-zone from two different, from one zone to a different zone, or intra-zone, where you're allowing traffic from a given zone to interfaces in that same zone. So that's required for traffic to flow. Now here's our packet flow, and this is one of the diagrams, and when I teach the security courses, I tell my students, hey, you have to memorize this process. Print it out, put it in your mirror so that you see it every morning while you're brushing your teeth, or something like that. So this is basically how an SRX box works. So you see that the traffic comes in, and if you have any kind of firewall filter or policer applied to the interfaces, that's going to be processed in a stateless format, in stateless mode. So it's packet by packet processing. But after that, you enter what is called the flow module. So this is all stateful processing of the traffic. So the first thing that the firewall is going to do is check if there is a session already created for that traffic. So we're looking for an entry on the session table that has the same source and destination address, port numbers, protocol, and see if that traffic was already accepted and use that information. If not, the traffic is going to go through the first path where we're going to evaluate the traffic against all the different security components to decide what we need to do with that traffic. So we see the first step is called screens, and here we're looking for basic types of attacks that we can discard pretty easily, like ping sweep and TCP port scans and so on. Then we do destination net, and after we do destination net, we look for a route in the routing table. Now at this point, we know that the packet arrived on a given interface, let's say gig is 000, and we know that that interface is associated with the on-trust zone. So we know what's the ingress zone at this point. So we look at the routing table, we figured out which interface we need to send the traffic out of, maybe gig 002, and we know that gig 002 is associated with the trust security zone. So now we know the inbound zone and the outbound zone. With that information, and that's what they point out right here, with that information, I will be able to figure out which security policy needs to be applied to the traffic. So I won't be able to apply any security policy until I know which zone the traffic is coming from and what zone the traffic is going out of. All right? So we apply the policy, and the policy might accept the traffic and inspect it and do all kinds of stuff to it. And then we apply source NAT, any kind of ALG, that's application layer gateway. And then we create a session, so next time that we receive traffic for that same flow, for that same combination of addresses and port numbers, we don't have to go through all the first pass details, but we just go through fast path and forward the traffic much quicker. So the key that I wanted to bring up in this slide is the fact that we do destination NAT, so we are translating the destination address before we do a route lookup. So that is going to determine the outbound security zone. And once we have that information, we can figure out what policy is going to be applied to the traffic. Now you can have routing instances and security zones configured at the same time on your Juniper SRX. But there are certain rules that you need to meet in order for this to work. In fact, you are not going to be able to commit if your configuration doesn't follow these rules. Zones can be applied, or a logical interface can be assigned to a zone. We know that. And a logical interface, gig 000.100, it's a logical interface, cannot be part of multiple zones. In the same way, routing instances, logical interfaces can be assigned to one and only one routing instance. And then they tell you that all interfaces in a zone must belong to the same routing instance. So this first one, I mean, these two are pretty straightforward, pretty easy to understand. This one is the one that confuses people sometimes. And this is actually the one that causes your configuration to fail the commit. So let's take a look at this picture right here. They're telling you that you assigned interfaces to zones, and we also assign interfaces to routing instances. So if these two interfaces belong to zone A, and port 1 belongs to this routing instance, or in this case is the master routing instance, INET 0, then this other interface that is part of the same zone has to be part of the same routing instance, the same routing table. To make it a little bit more clear, I have some examples here. So let's say that I have two security zones, and this is all part of INET 0, so this is easy. And I have three interfaces assigned to zone 1 and a single interface assigned to zone 2. So that one is pretty straightforward. Now these two other options right here, notice that now I have routing instances created. I have VR1 and I have VR2. So gig 002.2, it's part of this routing instance and it's part of zone 2. So that one, it's not complicated. Now here I have three different interfaces on the same routing instance on the same security zone. So that passes. Now this one is an interesting case. I have a single routing instance and all four interfaces are part of that routing instance. However, These three interfaces are on zone 1 and these interfaces on zone 2. That also passes all the validations because the rule says all interfaces within the same zone need to be on the same routing instance. So these three interfaces are on zone 1. They are all on the same routing instance. This one is an example of an invalid configuration. And it's pretty obvious that gigi 000.0 was configured on 2 different zones, and obviously that doesn't work. Now this one is an example where I have these 3 interfaces all under zone 1, but gigi 000 is on one routing instance, while gigi 001 and 002 are on a different routing instance. So that's a clear violation of the third rule that we saw on the previous slide. So that one doesn't work. And the last one is almost identical to this one because gigi 001 and 002 are part of one routing instance, while gigi 000 is part of INET 0. I purposely remove this link right here so it's not connected to the routing instance. So it's again 3 interfaces on the same security zone, but they are not part of the same routing instance. So that breaks the rule. Security zones, or actually zones, can be divided into 2 big groups: user-defined, which are configurable, and system-defined, which are not configurable. Within the user-defined, we have security zones and functional zones. Within the system-defined, we have the null zone, which doesn't allow any traffic, and that cannot be changed. All interfaces fall within that within that zone by default. And the Junos-Host is kind of a special kind of zone that I can use to protect my SRX. So I can use that Junos-Host zone to filter traffic coming into my SRX, SSH, Telnet, and stuff that it's being terminated on the SRX itself. Security zones are the ones that you create as a component of your security policies. So they must be created. There are no predefined security zones. There are some exceptions on the smaller end of the SRXs, the branch SRXs. The 210, for example, has some defaults. But the big SRX boxes that you're going to find on a typical enterprise network, they are not going to have any default zones. So you're going to have to create them. And it's a must because your interfaces won't be able to carry any traffic until you create your security zones and you move your interfaces into your security zones. So they filter transit traffic. That's another important detail. So this is for transit traffic, traffic that is coming into your SRX and it's leaving your SRX. It's not traffic terminating in your SRX necessarily. You are going to have security policies for intra-zone traffic, so 2 interfaces within the same zone, and for inter-zone traffic, traffic coming in on a given zone and going out of a different zone. I can also filter traffic destined to the device itself, and we'll talk about how that happens. And again, it cannot share between routing instances. If you have 2 interfaces within the same security zone, they have to be part of the same routing instance. Functional zones are, as I tell you here, special purpose zones, and they are used for out-of-band management of your box. There's only one option. There's one possible name that you can use for functional zones, and it's management. This type of zones cannot be referenced in security policies, and they do not pass transit traffic. The idea of a functional zone is to create the same behavior that you have for the FXP0 interface, and I don't know how familiar you guys are with the FXP0 interface, but basically any traffic that comes into the FXP0 interface has to terminate on your router, switch, or firewall. FXP0 does not allow transit traffic to go through your box. Now, FXP0 has some limitations. For example, I cannot place the FXP0 inside a routing instance. So, well, how do I simulate, or how do I have a behavior similar to the FXP0 using a physical interface, for example, GIGI000? Well, I will basically create this functional zone and place GIGI000 within that functional zone to, again, get the same behavior that FXP0 will have. And there's an example of that coming up later. System-defined zones. We have the null zone, which is not configurable. Every interface belongs to that null zone, and there's no traffic allowed, with the exception of the out-of-band management interface, typically FXP0 or EME0 if you have a switch. And once you configure security zones, interfaces are moved from the null zone to that new security zone that you created. If you delete the interface from the zone that you created, it comes back into the null zone. So if you remove the interface from a security zone, that interface will start blocking traffic again. So Junos rejects all traffic to and from interfaces in the null zone. Remember again that FXP0 doesn't follow those rules. Even though it also belongs to the null zone, it is going to allow traffic in and out, but traffic terminating on your SRX and only terminating on your SRX. And in that case, you don't require this hosting bound traffic command that we're going to talk about in detail in a little bit. Junos-Host zone is an interesting zone. You don't have to configure interfaces. You can configure the hosting bound traffic. The idea of this zone is to create security policies for traffic destined to the local device. So you will see in a few minutes that there's different ways to control traffic terminating into your SRX. The hosting bound traffic is one of them. You can also configure a security policy from any zone to the Junos-Host zone. And you can actually have the two things configured at the same time. So you can be blocking traffic terminating into your box in 3 or 4 different places within your configuration. Oh, and the other benefit of using this Junos-Host zone is that you have granular control. If you have hosting-bound traffic SSH, for example, or protocols or system services SSH, that allows SSH from any device that is accessing that particular zone. Let's say that here on the trust zone, under the trust zone, I configure hosting-bound traffic system services SSH. Well, that's going to allow all SSH traffic terminating on this trust zone. Well, maybe I want to be more specific. Maybe I only want host A to be able to SSH into my box. Well, hosting bound is not going to help me. I would need to write a policy from zone trust to Junos-Host zone. And in that policy, I can say only the source address can SSH into my box. So it gives you more control over who has access to your box. Factory default zones, again, are only available on some models. branch SRX, a small SRX 200s to 10s. They have built-in configuration templates with these two different zones on trust and trust. There is a single interface associated with the on-trust zone, and they assume that that interface is going to be used for internet connectivity, and every other interface belongs to the trust zone. Not only they have these two different default zones, they also have default security policies. So there's a policy from zone trust to zone trust that permits all, from trust to untrust permits all, and from untrust to trust it denies all traffic. And if you don't want to use this, you can create your own zones and move everything to these new zones and create your own security policy, so you're not restricted to doing it this way. Traffic coming into your box can be either exception traffic and transit traffic. And I have had students in the past who don't really like the idea of calling these exception traffic, but that's the term that Juniper uses. But think of it as control traffic. So control traffic is traffic terminating into your security device. So for that, for that control traffic, we're going to get into the details in a little bit. For transit traffic, traffic that it's not intended for the firewall itself, we will check if there is a security policy or a global policy that matches that traffic. If there is no policy, no security policy or global policy that matches the traffic, we apply the default policy, which typically is reject all. If it does match the security policy, then we check, okay, it matches a security policy. What does that security policy say? Does it say permit traffic or does it say drop traffic? Now for exception traffic, the process is way more complicated, as you can see here. The packet comes in, and again, we have determined that this is exception traffic already, but it could be intended for the ingress interface. In other words, if you let me go back for a second to the diagram here, if I am host A, I could try to SSH into the address of JNCIE 000. So it's the interface where the traffic is coming in. Is the same destination address of that traffic. I could also come from host A and try to SSH into JNCIE 100 or the lookback interface inside my SRX. So my SSH traffic is coming in on JNCIE 000, but it's not, it doesn't have a destination address on JNCIE 000, but on another interface. So that's what this is referring to. Is the traffic intended for the ingress interface or not? If it is, then the process is much simpler. We just check that there is a host inbound traffic command that allows the traffic. If it allows the traffic, we continue. If it doesn't allow the traffic, we just drop it. Now, if the host inbound allows the traffic, then we check if there is a Junos-Host zone security policy. So your traffic not only has to match the host inbound for the zone, it also has to match that security policy that terminates on the Junos-Host zone. So going back to that diagram, if A is trying to SSH into JNCIE 000, that traffic will have to pass the host inbound traffic associated with the trust zone, and will also have to pass the security policy from zone trust to zone Junos-Host. So two different places where you can block that traffic. Oops, sorry. Now, if the traffic is not intended for the ingress interface, things are a little bit more complicated. We check if there is a security policy that matches the traffic, because I might be coming on GIGI 000, but I'm trying to SSH into GIGI 100. And 000 is on the trust zone, 001 is on the untrust zone. So I need a security policy for that traffic. So we check for that. And so we say, does a security policy match the traffic? If there is nothing, we look into the global policy. And if that doesn't match, or if there is no match in the global policy, we apply the default policy, which again is drop by default. Now, if the security policy allows it, and the hosting bound traffic allows it, and the Junos-Host policy allows it, then we allow that traffic. So it's 1, 2, 3 different places where I can block that SSH traffic intended to terminate into my SRX. Not only that, it doesn't show you in the diagram, but I still need to go on the system services and enable SSH. And there is a possibility of having a firewall filter applied to the lookback interface, which could also be blocking SSH. So multiple places where you can make mistakes and prevent your control traffic from actually going through. So what are the steps to configure security zones and zones in general? We define the zones, either security or functional. We add logical interfaces to the zone. And optionally, we configure the hosting bound traffic command for either system services or for protocols. Now, even though it's optional, meaning you can commit your configuration without having any hosting bound traffic command in place or in your config, you really need to have the hosting bound traffic in most cases. If you want to allow the OSPF to work, you need to allow that traffic to come in. If you want your IPsec tunnels to come up, you need to allow IKE to terminate on your SRX. Even for MTP, if you want the router to provide clock for routers downstream, then you need to allow NTP as part of your hosting bound traffic configuration. So it is optional, but it's usually configured. Here's how we configure the zones. This is step number 1. We do set security zones, and this is kind of like a tongue twister. Set security zones, security zone, and then the name of it. Or set security zones, functional zone, and management is the only option that you have in that case. This name is whatever you want. This has to be management in all cases. Then you apply or you attach logical interfaces to the different security zones or functional zones. So you just go under Edit Security Zones, Set Security Zone, and the name, let's say Trust, and then interfaces GIGI 001.0. If you want these interface to act as the FXP0, you do Set Functional Zone Management. Again, this is the only choice. Interfaces, and then GIGI 001.100. The hosting bound traffic statement allows traffic destined to the device itself. This is, again, an optional step that in most cases is going to be required to make things work on your setup. So notice that in this example, they have hosting bound traffic allows SSH, allows ping, and denies telnet. And I can do that for the entire zone, or I can do it on an interface basis within the zone. The hosting bound traffic has two choices. I have system services or protocols. Within system services, you have services such as HTTP, HTTPS, SSH, DNS, and so on. You can specify all, or you can specify any service, where all is anything on their default ports. Any service is everything. Doesn't matter what port it is, I'm going to allow it. For protocols, you have the typical things, OSPF, BGP, RIP, and so on. You can also specify except. So for example, I could do system services all and then system services HTTPS except. So basically allowed everything but certain things. And once again, you can configure this at the interface or the zone level. Here's an example. We're going under Edit Security Zone and we're doing Set Security Zone Trust. This is the name of the zone that you decided to use. Host inbound traffic system services ping. So this system services applies to every interface under the security zone trust. At the interface level, we have Set Security Zone Trust, interface gig 001, host inbound traffic system services SSH and ping. So in this configuration, gig 001 will accept SSH and ping. Any other interface under the trust zone will only accept ping. The interface level configuration overrides the zone level configuration. Just like, to give you another example, in policies, if you guys are familiar with writing policies, if you have an export policy applied to BGP and an export policy applied to a specific neighbor, well, this policy is what this neighbor uses, and the global policy is what the other neighbor uses. Same idea. Here's some examples. The first one is under the security zone external, I have host inbound traffic, system services all, but then I say system services telnet except. So I will be accepting everything but telnet in this security zone. Now, I have two interfaces associated with that security zone. Gig 000 doesn't have any host inbound traffic command, so this interface is going to be using this. While gig 001 has its own host inbound traffic system services command. And this one says system services all, HTTP except, FTP except. So gig 001 won't be able to do FTP. But gig 000 will be able to accept FTP. The second example is for security zone trust. So I have the host inbound traffic configured for the zone, and none of my interfaces have the host inbound traffic command. So all three of them will accept SSH and FTP. The last one, security zone on trust, has host inbound traffic system services SSH and FTP. And then gig 001 has SNMP. So any user trying to SSH or FTP on gig 001 will be blocked because gig 001 only accepts SNMP traffic. Let's talk about the Junos-Host zone a little bit more. We are configuring the zone on trust, and notice that under that zone I have host inbound traffic, system services, ping, FTP, and these are my two interfaces. So based on this configuration only, any user can ping, any user coming in on these two interfaces will be able to ping and FTP my router or my SRX. I want to be more specific. I want to be as specific as only certain sources from this interface or that interface will be able to ping or FTP. So I'm going to leave this configuration in place because I still need this, but I'm also going to configure these security policies. So under Edit Security Policies, I'm doing from zone on trust, and this is again the zone that I created right here, to zone Junos-Host. This is one of the built-in zones. And I have two policies. Policy deny ping, it says from source address 172.20.1.10, destination address any, application Junos ping. And the action I'm going to take is deny. So combining these two sections of the config, any user coming in from any source except for 172.20.1.10 will be able to ping. The second example is similar, but it's matching on 10.10.10.1, Junos FTP, and the action is permit. So for FTP, any user, 10.10.10.1 will be able to FTP, nobody else will be able to. But again, remember that I don't replace the hosting bound traffic command with my policy. I have this in place, and on top of that, I have my Junos-Host policy to make it more granular. And here's an example that is similar. So I have hosting bound traffic configured under this interface, and then I have a Junos-Host policy that matches on specific source address and denies that traffic, and the other one matches on application telnet and allows that traffic. So this is making it more granular. How do I monitor zones? Well, you do show security zones, for example, and you can do extensive or details to get more information. This example shows you that there is a functional zone management, and it tells you policy configurable. No, you cannot touch this. You cannot use this zone within a security policy. And then it shows you the interface that it's associated with that management zone. There's another one called HR, and this one is configurable within a security policy and has these interface enabled. You can also look at the interfaces. This is probably one of the quickest ways of figuring out why your protocol is not working. For example, I don't see OSPF adjacencies out of GIGI 003.200. Well, one quick, easy way to figure out if OSPF is allowed by the zone configuration, it's by just typing show interfaces GIGI 003.200 extensive and look for this section of the output. It tells you that this interface, it's part of the trust zone, and it gives you the list of all the system services and protocols that are allowed by the hosting bound configuration under the security zone. It also shows you some statistics. Now let's talk about the functional zone in a little bit more detail. It's used again for out-of-band management, and the only name allowed is management, as I mentioned earlier. It cannot be referenced in a security policy. It cannot pass transit traffic. So the whole idea of this functional zone is to create a similar behavior to what you get when you use the FXP0 interface, which only allows traffic terminating in your box. Now, if I already have the FXP0 interface, and this is a question that I get from time to time from my students, if I already have my FXP0 interface for out-of-band management, why would I need to create this functional zone? Main reason is your FXP0 interface can only be part of INET.0. So you cannot have, for example, a default route pointing out of FXP0 and a default route pointing out of another interface and avoid conflicts. To use different or explain in a different way, you don't have separation between the routing table that you use for out-of-band management and the routing tables that you use for your transit traffic when you use the FXP0 interface. So that's the main reason why we use the functional zone. So here's a little diagram that shows you why I would want to do a functional zone. I want to use JNCIE 002 as management. I want this interface to behave as if it was the FXP0. It allows traffic only for management purposes, terminating on my SRX. But I want that management interface to be part of a separate routing instance, so that the routing that I use on this routing instance doesn't conflict with the routing information that I have in the rest of the firewall, in inet.0 or any of my customers' routing instances. I can't do that with FXP0 because FXP0 cannot be configured within any routing instance. So here's the config for that. So I have security zone, functional zone management, and this security zone, or not security zone, this functional zone allows interfaces. So I'm doing JNCIE 002, it's part of the functional zone, it has an own address, and it is part of a routing instance. This last command right here is what makes big difference between using this idea and using FXP0. So now I can have my own routing table for management purposes. And I can have a default route in this routing table that doesn't interfere with my transit traffic, or the default route that I might want to use for my transit traffic. All right, so that was the last thing that I wanted to talk about. And thank you, everybody, for being here.